Hello, Algebra 2 folks, and welcome to Cube Root Functions. Today you're going to need your graphing notebook or some graphs, a writing utensil, and a calculator. Okay, let's go ahead and get started. So we are going to take a look at the cube root graph, which means now my index is a 3. So when I talked about square roots, that was a 2, and now it's a 3. So if I were going to plug some values into my table, I might start with -2 and see what happens. For square roots, it didn't work. Let's see if it works for cube roots. So the cube root of -2, wow, yeah, it works. -1.26. Yeah, pretty good. So we can take the cube root of negative numbers. So let's try -1. The cube root of -1, yeah, -1. The cube root of 0, 0. The cube root of 1, well, that'd be 1. And the cube root of 2 would be a positive 1.26. So if I were to graph these on a graph, -2, -1.26, -1, -1, 0, 0, 1, 1, 2, 1.26, it kind of makes this nice little S shape. It's called a sigmoidal shape, or maybe a snake shape if you want to call it that. And when I get my sigmoidal shape, or that little S shape, now we can take a look at the domain and range. So for square roots, we weren't able to square root negative values, but we are with cube roots. So we can have negative values, we can have 0, we can have positive values. That means our domain can be anything. So our domain is all reals. Well, now when I look at the range, here's my range. My range is some negatives, 0, and some positives. So your range can be anything as well. So your range is all reals. So cube root graphs have a domain of all reals and a range of all reals. Pretty sweet. All right, so do you remember talking about shifting with square roots? Well, the same idea happens with cube roots. Okay, so cube roots can be shifted as well. Just because I changed the index doesn't mean the rules change. Okay, so if I added a k, my graph would vertically shift that k units either up or down. If I had my h be added to this function, that means my graph is going to move left or right. If I have an a in front, I'm going to either have some stretching or compression, or narrowing or widening. If I have the negative out in front, I'm still going to have a reflection. So it doesn't matter if I have a cube root or a square root. These same kind of shiftings continue to happen. All right, so if we're going to take a look at this graph, it says the cube root of x minus 2 plus 1. This means my graph is going to move right 2 and up 1. Now that's not where we're going to start our table. That's where we're going to put our middle of our table. The reason why it goes in the middle is because, yeah, square roots couldn't have negatives. Cube roots can have negatives. So we want values on both sides of this 2, because we can have some negatives in our cube root. So when I make my table, I'm going to start with where my shifting, put it in the middle, and then come up with some values on both sides. So that could be 1 and 0, and this could be 3 and 4. Then I'm going to plug all these values into my x and find my answer. So I'm going to go the cube root of 0 minus 2 plus 1. The cube root of 0 minus 2 is -2. The cube root of -2, remember, is negative 1.25. Add the 1 to the end, and I'm going to get negative 0.25. Okay, now let's plug a 1 in there. The cube root of 1 minus 2 plus 1. 1 minus 2 is negative 1. The cube root of negative 1 would be negative 1 plus 1 would be 0. Now let's plug in 3. The cube root of 3 minus 2 would be 1. The cube root of 1 is 1. And 1 plus 1 would be 2. Now if I plug in 4, the 4 minus 2 would be 2. The cube root of 2 is 1.25 or 1.26. You know, that little bit of a difference isn't going to really matter. So 1.26 plus 1 is going to give me 2.26. So I'm going to graph these values. 0, roughly a quarter down, so negative 0.26, 1, 0, 2, 1, 3, 2, and 4, 2.26. And then I'm going to make kind of an S shape. I got to make an S shape through these, or I don't have a cube root function. Remember, all functions have a certain shape, and we want to continue that shape. And the domain and range, once I have that S shape, is all reals. X such that x equals all reals, y such that y equals all reals. Okay, let's try it one more time. Here I've got g of x equals negative cube root of x plus 5 underneath the radical minus 3. So I have a cube root, and I have some shifting. So this is going to move left 5 and down 3. And so that is going to be the start of my middle of my table. I'm going to plug some values in less than negative 5. That'd be negative 6 and negative 7. And negative 4, negative 3. Those seem like reasonable values I can plug in my calculator. And then I'm also going to just make a mention that I do have a negative out in front. So I should see some reflecting happening. So the S is probably going to look maybe a little bit different. Okay, so let's see what's going to happen with that. So let's plug the negative 7 in here. Negative 7 plus 5 is negative 2. The cube root of negative 2 is negative 0.126. But we have this negative that we have to bring out in front as well. So I have negative 1.6 minus 3. That's actually 1.26 minus 3. And 1.26 minus 3 is going to give me negative 1.74. Okay, now let's type in a negative 6. Negative 6 plus 5. That's going to give me negative 1. Remember, I have a negative out in front. Cube root of negative 1 is negative 1 times the negative out in front. That'll give me a positive 1. And then subtract the 3, and I'm going to get negative 2. And this 3 should be a negative 3. I apologize for that because it's down 3. All right, then let's plug in the negative 4. Negative 4 plus 5 would be 1. The cube root of 1 would be 1 times the negative would be negative 1 minus 3, which would be negative 4. Plug in the negative 3. Negative square root negative 3 plus 5, which would be 2. The cube root of 2 is that 1.26. Bring that negative out in front again. Can never forget that if we have a negative. Negative 1.26 minus 3 would be negative 4.26. So then we're going to plot those. Remember, when we plot them, we need to get that nice S shape. So negative 7, negative 1.74, negative 6, negative 2, negative 3, negative 5, negative 4, negative 4, and negative 3, negative 4.26. this looks like my S is going in the opposite direction. Kind of looks like a backwards S now. And that should happen because we had a reflection. Now that we have it graphed, what about our domain and range? Well, remember, we can have all sorts of problems with domain in a cube root. So that means it's all reals. And same thing with the range. So it doesn't matter if I have a forward-facing S or a backwards-facing S, we will have a domain and range of all reals. Okay, that's all I have for you folks. We'll see you tomorrow to begin working and practicing more of these.